We're going to use our polynomial and quadratic skills to solve a few problems today. So we've got this ball being thrown straight up and an equation that gives its height. We want the height 2 seconds after it's thrown. Well, if our amount of time in this equation is 2 seconds, we're just going to plug in 2 for t. Remember, h of 2 just means I'm taking 2 and plugging it in for my variable. And then if I simplify, 2 squared is 4. Multiply those together, it'd be negative 64 plus 90 gets you 26. Then that means after 2 seconds, I get a height of 26 feet for my ball that I threw up in the air. Let's look at an area problem. So we've got the area of a rectangle is given by that quadratic function. We know that if you think about area of a rectangle, area is length times width. So we're kind of trying to go back and figure out what two side lengths get multiplied together to get us 6x squared plus 7x plus 2, which essentially means that we need to factor it and see what two binomials we'd multiply together to get that area. I'm going to factor by grouping, so I'm going to find the two numbers that multiply to get me 12, 6 times 2, and add up to get me 7. 3 and 4 will do that. So if I break up my middle term into 3x plus 4x to rewrite it, then I have some common factors that I can factor out a couple of groups here. So I'll factor a 3x out of 6x squared plus 3x, which leaves me with 2x plus 1, and a 2 out of 4x plus 2. And then my red group and my purple group each have a common factor of 2x plus 1 that I can factor out. So my factored form is going to be 2x plus 1 times 3x plus 2, which means those are the two binomials that represent my side lengths that could be multiplied together to get this area. We've got a rectangular room, and we know its width is just w, whatever that is, and its length is 4 feet less than that. We know the area, and we want to find the dimensions of the room. So I'm going to jot down, I know my length is 4 feet less than my width, so whatever my width is minus 4. I'm actually going to draw a picture of this room. So if you think about the area, to get the area, I'd multiply my length and width together, which in this case would give me w squared minus 4w. And then I'm told that that area is 96 square feet. So I could write myself an equation and say that w squared minus 4w equals 96. And then solve it. So we know we want to get 0 on one side since it's quadratic so that we can do some factoring. So I am going to guess and check on this one because I like to do it that way when it's just a 1 something squared. So 12 and 8 I think would multiply to get me 96, and 12's got to be negative. I'll multiply it together and check. Yep, that works. So if I didn't get it correct on the right first guess, I'd have to try again. Set each of your factors equal to 0, and then add 12 to both sides my first one, subtract 8 on my second one. I get w equals 12 and w equals negative 8. But if you think about what w represents, it's the width of my room. So w equals 8 doesn't make any sense. And in the context of this problem, we're going to have to throw that out. So we just have a width of 12 feet. The question asks for the dimensions of the room. So if I plug 12 back in, I'll get 8 feet for my length. So 12 foot by 8 foot room. We've got this diagram with a rectangle and a triangle inside of it. They tell us that the blue shaded area is 16 square units, and part A says we want to find the value of x. So we need an equation that we could write to relate some of these things. So I could think about like the areas of the hole in the shaded and the triangle and how they relate. I could do my rectangle's area without my triangle's area equals 16. Or I could say if I take the triangle's area and add up the blue area, I'd get the total rectangle area of 16. So I'm going to go with that one because it involves addition instead of subtraction. Area of my triangle is 1/2 base times height, so it'll be 1/2 times my x times x plus 2. And then area of rectangle is just multiply your base and height together. So x plus 3 times 2x. I'm going to distribute and simplify a little bit here. If I multiply my 1/2 x times x plus 2, I get 1/2 x squared plus x. And then 2x times x plus 3 gives me 2x squared minus 6x. It's a quadratic, so I want 0 on one side so I can factor. So I'm going to subtract 2x squared and 6x from both sides. We could subtract 1/2 x squared and x and 16 if you prefer. To subtract my 2x squared, I'll go ahead and get a common denominator. So that'll give me negative 3/2 x minus 5x plus 16 equals 0, which isn't something that looks really fun to factor. We could do it, but we'd have to use fractions. We could also make our lives easier if I multiplied both sides by 2, since my denominator of my fraction's 2. That would make all these whole numbers, so I'm going to do that. So if I multiply everything times 2, I'm going to get that result. And then I, again, don't really love to factor when it's got a negative, so I'm going to also multiply both sides by -1, which will switch all of my signs and give me a positive 3x squared, a positive 10x, and a negative 32. Since we already had 0 on the right-hand side, multiplying it by 2 and -1 isn't going to change it. Okay, now I'm going to factor. I'm going to, since it's a little bit of a harder one, find the two numbers that multiply to -6 and 96, sorry, and add up to 10. Things that multiply to 96. 8 and -12, nope. 16 and -6 will do it. So I can rewrite my middle term and then make a couple groups, factor out my common factor. I can factor out an x, which leaves me with x times 3x plus 16, and I can factor out a -2, which would leave me with a positive 3x plus 16, which is good because that means that I have a common factor of 3x plus 16 that I can factor out, and then I just have it times x minus 2. If I set each of those factors equal to 0, I'm going to get my potential values for x. So subtract 16, divide by 3, gives me -16/3. Add 2, gives me 2. Now 2 times x is the bottom side length of my rectangle, so I can't take 2 times -16/3 and get a side length because that'd be negative. So only x equals 2 works. If I want the area of my triangle, I'm just going to take my 1/2 base times height and plug in what I got for x. So you'll have 1/2 times 2 times 4, which is just going to be 1 times 4 is 4 square units. So we got two rectangular prisms, or basically boxes, and we're talking about a larger one and a smaller one. We want to know how many times greater the bigger one is in terms of volume than the smaller one. So if I'm finding volume, I would multiply my length times width times height, or all 3 dimensions together. So I'm going to jot that down for my 2 rectangular prisms here. And then if you think about how you could find how many times greater one volume is than the other. Say my larger volume is 10 and my smaller volume is 2. One way you could do it is go 10 divided by 2 means that my volume of my bigger one is 5 times as big. You could also think about breaking 10 down into 5 times 2 and going, oh, well, it's 5 times my smaller volume of 2, which I think is going to be easier on this one for us because I don't really want to multiply all of this together and then do long division. So let's factor this. So I could factor 2 out of my 2x plus 2. I could factor another 2 out of my 4x minus 2. And then I'll go ahead and break down my 6x into 3 times 2 times x. If you look at your smaller rectangular prism, there are no common factors there. So I'm just going to rearrange and compare a little bit here. So I'm going to put my 3 factors of 2, factor 3, and then times my x plus 1 and my 2x minus 1. So if you look at what factors are shared, both of our prisms have factors of x plus 1, 2x minus 1, and a 3x. The difference is my bigger one has 3 more factors of 2 being multiplied than my smaller one. So it's essentially 8 times the expression that represents my volume of my smaller rectangular prism, which means that if I'm talking about how many times bigger this one is than my smaller one, well, it's 8 times larger.